Hello, in today's video, we're going to talk about compounding interest. Now, this is going to be a long video. I apologize for that. I'm going to save us a little bit of time. I'm going to put the questions up on the screen here so I don't have to write them, and so I have more room to do work. That's a sign for how much work some of these will be. So this first question here says that Sarah invested $800 in an account paying an interest rate of 3.5% compounded quarterly. Assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 8 years? So we're going to use this formula for this question. A equals P, parentheses, 1 plus R over N raised to the NT. This is a formula you have to memorize, unfortunately. This is the formula to calculate compounding interest. Just really quickly, how compounding interest works is that when you give your money to a bank and they hold on to it, in return for you letting them hold their money, they pay you a little bit. And the reason it's called compounding is the longer they hold on to it, the more money you'll earn, because not only did you give them a little bit of money to hold on to, now that extra money that you earned over time is also going to accrue interest. So this formula is the formula to calculate how much interest will be involved. Okay. So this question, Sarah invested $800. P in this formula is called the principal. And the principal value is how much money we started with. So in this question, Sarah started with $800. She had an interest rate of 3.5%. So the R here is the rate. So R is the rate. Now, whenever you do rates in this formula, the rate has to be a decimal. And almost always they're going to give it to you as a percent. So in this question, we have a rate of 3.5%. That means that R is going to be 0.03. Remember, you divide that number by 100 or move the decimal 2 spaces over. So our principal in this question was 800. I forgot to write that down. Also in this question, it says that we're compounding quarterly. What that means is when they calculate interest, they can change how often they hand you that interest. Some banks offer it monthly. Some banks offer it quarterly. Some banks offer it yearly. So when they say they're offering it quarterly, that means 4 times a year. They're going to say, wait, stop. How much money's in your account? Okay, here's some interest. And they're going to do that 4 times a year. So that means N is a number of payments per year. And in this case, N is 4 compounded quarterly. All right. And then finally, the last piece of information here is T. And T represents how many years. And in case you're wondering why it's T, well, T stands for time. But we always want to measure in years unless the question has some weird stuff going on. So in this case, T is 8 years. So we have all the information we need to use this formula. And luckily, in this question, the formula is set up to solve for A. This question's asking for how much money is in the account after 8 years. So A is the final amount. In this case, we don't know A, so we're looking for A. So this question, all we have to do is put all those numbers into the formula. We don't have to manipulate it all. We don't have to do anything special. So we're just going to do A equals principal, parenthesis, 1 plus the rate was 0.035 divided by 4 times a year. And then the exponent is N times T, so 4 times 8. Now, no sense in doing anything special to this formula. We have a calculator. So let's just type all that in. You can do it all in one step. So 800 parenthesis 1 plus, I'm going to use my fraction button to make sure I get that fraction set up right. And then I'm going to do my exponent as 4 times 8. I hit enter. This question says, let's solve to the nearest cent. So the answer is going to be 1,057 and 22 cents because the decimal on the screen says 0.215. So we need to round that to 22 cents. So this question here, all that work was to just plug it into the equation that you have to memorize and then using our calculator to get the answer. So that was the first question. Let me pause for a second here and get going on the next question. All right, next question. Matthew invested $5,800 in an account paying interest rate of 4.9%, compounding continuously. Assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 7 years? This seems like almost the exact same setup of the last question. However, it's a very different question. And that's because it says the words compounding continuously. As soon as you see compounding continuously, we have a different formula to use. Compounding continuously means that it's compounding infinitely for every microsecond that the money is in the account. Usually it says monthly or weekly or daily or yearly, but whenever you hear compounding continuously, that means they're always calculating an infinite amount of times how much interest is accumulating in this account. But it works very similar. If you see compounding continuously, use this formula. And again, it's not given to you. You have to memorize it. So P is still principal. And in this question, the starting value is $5,800. R is the rate. Remember, we want the rate to be a decimal. So our rate is 0.049. And T is time in years. And in this question, they want it to be 7 years. So T is 7. Now remember, the letter E is not a variable that we pick what goes in it. It's a very set value. It's called Euler's number. E is approximately 2.71. And we use that whenever we're dealing with some exponential growth. We're not going to try to remember the value of that. We're not going to worry about rounding it. We're just going to use the E button on our calculator. So once you have all that information figured out, this formula just wants us to plug it in. So P is 5,800. E is just going to stay as E. R and T are the exponent, 0.049 times T, which is 7. We're just going to type all of that on our calculator all in one step, hit enter, and then make sure we round correctly. So 5,800 times, the E button is on the divided by on your calculator. So E raised to the 0.049 times 7. And they say round this to the nearest cent. So our answer is going to be $8,173.18. So that's how you do it when it's compounding continuously. All right, now what they're going to do in these questions is they're not always going to have you solve for the ending amount. They might ask you to solve for R or N or T. So let's take a look at question 3 here. Ella invested $2,700 in an account paying an interest rate of 5.4%, compounding monthly. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach $4,020? So this is one of those examples where they're not asking us to solve for A, they're asking us to solve for how long would it take. So they're asking for us to solve for T. So let's put in all the values we know. The ending value is 4,020. So that's going to be our A. P is our starting value. So that's going to be 2,700. R is our rate. We do know our rate, but we need it as a decimal. So 0.054. This is being compounded monthly. Remember, n is how many times in a year are we compounding? So n is going to be 12, and then n is also up here, and we don't know t. That's what we're solving for here. So we're going to leave it as t. All right, so to solve this, we have a completely different process because the variable is in the exponent. So we need to solve by trying to get this variable all by itself, and that's going to take a lot of steps here. So first step, let's get this t all by itself by getting this 2700 out of here. We can't deal with anything inside here because, well, we could. Everything in there is a number, so we could calculate it, right? But we'll save that for a second. Let's divide by 2700. So 2700 is divided on both sides. I'm not going to calculate that. I'm just going to leave it as a fraction. 4020, 2700. We'll save that calculation for later. And if we divide by 2700, what's left over here is all this parentheses stuff. All right, now, when you have a variable in the exponent, you have to solve using logarithms. Let's do a simpler example over here in the margin. If I have 2 to the x equals 8, I know the answer to that is 3. But if I don't know the answer because it's complicated decimals and weird fractions, I need to use logarithms to do this. Remember, logarithms work like this. You write the word log. The base that the exponent is attached to is the base of the log. The exponent becomes the answer, and the number that was the answer becomes what we log. So basically what happens is the base stays the base, and then these two things switch spots. So that goes over there and that goes over there. Why would we do that? Well, because now the variable is all by itself, and this is something that just has numbers in the word log. We can do that on our calculator. So let's do a similar setup over here. Log, the base of the log is the base that the exponent is attached to. So all of this goes in the log base. 1 plus 0.054 over 12. Remember, whatever the exponent is attached to, that's the base of the log. Whatever the exponent was, that becomes the answer to our problem. And the thing we are logging is whatever used to be by itself on the other side of the equation. So 4020 over 2700. So this is the problem we do on our calculator. This entire thing here can be typed on our calculator. And that's going to take a little bit of work here. If you can do it. So we're going to hit to get to log on your calculator. Remember, there is a log button. We can only use that if the base is 10. And I don't think that's 10. So the base of our log, we changed that by going to math and then going down to the bottom of the first screen that comes up, and you'll see log base is one of the options. And then it asks, well, what's the base of the log? We're going to type that whole problem in. 1 plus, remember, we want to not to get rid of that fraction here. So 1 plus, I'm going to use alpha y equals to make my fraction. 0.054 over 12. And then in parentheses is this fraction. 4020, again, I'm going to use alpha y equals to make my fraction. 4020 over 2700. So when you're done, I'm going to try to get the screen to focus here. When you're done, you're going to end up with, will it focus? That's as good as it's going to get, I think. Oh, there we go. So when you're done, you end up with f. Log 1 plus 0.054 over 12 based 4050 2700. It's a lot, I know. But when you type all that in and hit enter, we're going to get 88.65. And it actually has a bunch of zeros after that. So that means the rounding is almost perfect. 88.65. Now, we didn't do anything to that 12t, so we're just going to leave it as 12t. So our calculator did all that big, huge problem for us. And that was all equal to 12t. And then the last step here, we want to know what t is, but all this whole time, t's been multiplied by 12. And now that we have the t almost by itself and all of this is gone, our last step here is to divide by 12 and do that to both sides. Don't clear your calculator. Leave that big long decimal on your screen so you can just type divide by 12. And we get our answer here, 7.3875. The question said round to the nearest year. So our whole answer here is t equals 7 years. All that work to get an answer of 7 years. If we leave $2,700 in a bank account with 5.4% interest compounding monthly, it would take 7 years to get to $4,020. Good job if you followed along on that. That was a tough question. Good job. All right, next question. Nathan invested $75,000 in an account paying an interest rate of 6.8% compounded continuously. Assuming no deposits or withdrawals are made, how long would it take for the value of this account to reach $182,000 and $182,800 to the nearest tenth of the year? So I need to use a different formula because it said continuously. I need to use this formula. But all the process is going to be the same here. A is our ending value, 182,000. P is our starting value, 75,000. E is just E. We leave it as E. We don't change that. R is the rate as a decimal, so 0.068. And T is what we're solving for, so we leave it as T. So now, just like the last question, we need to get T alone. But first, let's get that 75,000 out of here by dividing by 75,000. Why do we move that 75,000? Because we can't do logs if this number's up front. Our log setup needs to just be a base with an exponent. A base with an exponent. That 75,000 can't be there for us to use logs. So again, I'm just going to leave that as 182,000 divided by 75,000. And this works out to E to the 0.068 t. Now I'm ready to use logs. So remember, log, the base of the log is the base that the exponent was attached to. So log base E. What we are logging is what is on the other side. So 182,000 over 75,000. And the answer is the original exponent, so 0.068 t. Now, before I pick up my calculator and do anything, I'm going to change this a little bit because log with a base at E has a special name. Mathematicians were using log with a base at E so much that they gave it a special name. That special name is ln. It's the same process, but really all that's different, there's a button on your calculator for that, so you don't have to hit math and go down to log base and type in the E. You can just save yourself a little bit of work by typing in ln. So let's do that on our calculator. The ln button is on the left near the 4. So we're going to hit ln, and we're going to type in our big whole fraction, 182,000 divided by 75,000. That was much simpler than the last one. And we end up getting 0.8865. 0.8865. I'm going to put dots here because that's not my final answer. I'm going to leave the decimal on my screen so that when I go to solve this, I don't have to worry about typing in all those values. Let's take a look real quick at what the calculator screen says here. You can see, hopefully, hey, you can see it was just ln of that big number, right? All right. Well, why aren't we done? Because I want to know t, and this t is being multiplied by 0.068. So I'm going to divide by 0.068. And that's why we wanted to leave it on our calculator, so that I don't have to type in this whole long decimal again, divided by 0.068. And we get 13.037. So that means we would need to leave this money in the account. We wanted it to the nearest 10th. So 13.1 years was the answer to this question. Oh boy, I'm not using that marker anymore. That blue marker was very, very stinky. Whew. Anyway, next question. Thanks for sticking around. This is a long video, I know, but there's a lot of different things they can ask in these, and we just got to try all of them. So this question says, Rashad is going to invest in an account paying an interest rate of 7% compounded daily. How much would he need to invest to the nearest cent for the value of the account to reach $133,000 in 8 years? Let's go through all the values they gave us. They gave us 7%. So that means my rate is going to be 0.7. Compounded daily means our N is 365. And that's because N is how many times in 1 year is this going to be calculated? So 365 goes up here. They gave us T. T is 8. So we're going to put the 365 and the 8 up there. We don't know P. We don't know the starting value. But we do know the ending value is 133,000. So here's the setup for this question. And if we want to know the value of P, all of this is all numbers. We don't need logs or anything special. This can all be done on our calculator. And when we're done with all of this on our calculator, if we want to find out what P is, we just have to divide both sides by that value. So I'm going to type that all in my calculator. So we got parenthesis 1 plus, and I'll make a fraction here, 0.07 over 365. And that's all raised to the 365 times 8. I end up getting this whole thing works out to be 1.75057. I'm not going to write that down. I'm not going to round it. I'm just going to leave it on my calculator screen. Because ultimately, like I said, to get the P alone, we're just going to take that and move it all over there, dividing that. So that's what I'm going to do on my screen. I'm going to do $133,000 divided by, and since I don't want to type in the whole decimal again, what I'm going to do is I typed in 133,000 divided by, and then I just went up, I highlighted the last answer and hit enter. And what it did is it put the letters ANS there. Sometimes when you do it, it puts the actual decimal there. Sometimes when you do it, it just brings the value down. So actually, I'm going to try it again. 133,000 divided by, and then I'm going to go up and I'm going to highlight the last answer and I'm going to hit enter on it. And okay, this time it brought it down. So now I don't have to type it in again. I don't have to worry about rounding. I hit enter and we get our answer. It says that we need to invest $75,974.88. It did say round to the nearest cent, right? So our answer would be $75,974.88. And if you did want to show some work here, you can do this. P times 1.75. What was the rest of it? 0.578,506 equals 133,000. And we're just going to divide by 1.750578 out of 06. See why I didn't want to write that? Because that's a really long decimal. So that's the process that got us to this P value all by itself. All right, good job. All right, next question. Hakeem is going to invest in an account paying an interest rate of 3.5% compounded continuously. How much would Hakeem have to invest to the nearest cent for the value of the account to reach $147,000 in 13 years? This is our formula because we saw the words compounding continuously. And we want $147,000 as our end value. We don't know the start value. We're going to leave E as E because we know that our calculator will deal with them. R is the rate, so 0.035. Remember, it used to be a decimal. And T is time, so 13. All of this is calculatorable. Well, let's just go type it on our calculator. E raised to the 0.035 times 13. That all works out to 1.576. I will write it this time, but I'm going to just do dots because I'm going to leave it on my calculators. I don't want you to think we're allowed to skip steps. And then I want to know the value of P. So I need to divide by 1.576, dot, dot, dot. 1.576, dot, dot, dot. And I'm going to use my calculator for that. And I'm not going to do dots on my calculator. I'm actually going to just use the value that's on the screen. So 147000 divided by the last answer we just got. And we get $93,263.85. This question said to round to the nearest cent correctly. Yep. Great. Got 2 more questions to go. We're almost there. All right, this question says, Elizabeth is going to invest in an account paying an interest rate of 4.4% compounded quarterly. How much would Elizabeth need to invest to the nearest dollar for the value of the account to reach $189,000 in 16 years? So our ending value is $189,000. We don't know the starting value, but we do know the rate is 0.044. We know that it's compounding quarterly. That means 4 times a year. And our time is 16 years. All right, so this is just like the last question. So we find this as a decimal. We just have to divide. 19000. 1 plus 4 times 16. This whole decimal works off to be 2.01 roughly. Just to prove I'm not lazy, I'm going to write out the whole thing this time. And then we're going to divide by that 2.014067205. Even though I'm writing out the whole thing, I'm still going to use whatever's on the calculator screen. I believe the calculator still knows the decimals beyond what's on the screen, so we want to be as precise as possible here. So 18,900 divided by, and we get 938399. Rounded to the nearest dollar, so that means this P is going to be 93,840. I think I lost a 0. I did. I lost a 0 there. So 93,840 is our answer for that question. All right, we have one more question. You stuck through this whole time. Good job. Or one more to go. You can do it. All right, last question. Abigail is going to invest $630 and leave it in an account for 5 years. Assuming the interest is compounded continuously, what interest rate to the nearest 100th of a percent would be required in order for Abigail to end up with $820? So they want to end up with $820. They did tell us she started with $630. He is going to stay as an E. Our time is 5 years, but we don't know our rate in this question. So let's start. Oh, there are variables in the exponent. Well, the variables in the exponent, you have to use logs. Can't use logs until it's just a base and just an exponent. So let's get that 630 out of there. And I could simplify that, but I'm just going to leave it as 820 over 630. All right, there we go. We have what we need to do logs. So remember, our logs base is the base. So log with a base at E. What we're logging is what used to be all by itself. And the answer to a log question is the original exponent. So r times 5. We had a question like this earlier. When you have a log with a base of e, you can leave it like that. Your calculator will let you do a log with a base e, but we're going to save some trouble, and we're going to change it to be an ln. Log base e is the same as ln. So we just have to do ln of 820 over 630. And then when we're done, we have 5r. So when we're done with that whole decimal on our calculator, we're going to have to divide by 5, right? Because we want to get the value of r, not 5r. So I'm going to do that now. And I'm going to type that all at once on my calculator. And I'm going to get the answer without doing multiple steps. I will show you what I'm doing on my calculator here. 820 divided by 630. All over 5. So you can see, all in one step, I did the ln on top of the fraction, the divided by 5 on the bottom, and we got 0.0527169042. Now it's weird to get a small decimal here, right? But when you think about it, we were solving for the rate. The rate is 0.052716, blah, 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 blah. There might have been some rounding there. Yeah, technically this should be a 7. But anyway, this is a rate as a decimal. Every single question gave us the rate as a percent. So let's give them back what they want. Let's give them the rate as a percent. To turn a decimal rate into a percent rate, you multiply by 100. Or you just move the decimal twice. So that'll be 5.2717%. Let's make sure we're answering the question. Round to the nearest hundredth of a percent. So our real answer is 5.27%. Pooh! We did it. We did all 8 questions. Thank you so much for watching. Thank you for sticking around. Thank you for listening. Thank you for putting up with out of focus videos and me mumbling and a lawnmower in the background. So thank you so much. Have a good day. See you next time.